so a contour of velocity, and I can select here a Mach number. I'll select all the surfaces. Then in view here, I'll change the lighting option. So there you can see how your flow feed looks in the solution. So you will have an understanding of what's happening. So there is the circulation region, and somewhere here there is a reattachment point where the velocity is positive again. The Mach number also seems looks fine. There the maximum Mach number is 1.29, but we should check that the Mach number at this point, so at the center of x over h equal -4, is equal to 0.128. So to do that, we can create a line. So I'll go from domain, surface, create, line rake, and I can call this one, for example, x equal -4h. So this is a line, and the endpoints are the x, so this is in centimeters, so this is going to be -0.04 meters, also for x1 -0.04. Y, we are going to set a y in the middle of the domain, even though it doesn't really matter, the solution is the same for each y that is included in our range. So let's set this to -0.00. No.
I complete the calculation, but I didn't develop.
Sorry.
I complete the calculation, but how to develop?
This one, the contour.
Okay, they only create one line, right? Just to create, let's go to the next step. Create.
Yeah.
Okay. No, yeah, it's created because now it's giving you for the new line. Now we have to go to X solution, XY plot. Plots, XY plot. Post on X position on X axis. Without the limits. 0, 0, 0. Okay, what else?
For velocity.
Okay. And the new line. That's it. Do we have to do same plot? Order points. Yeah, same plot. Okay.
Ours is way better actually.
Wow. It's more correct.
I can just calculate in case again.
What is it? Mark number, right? Let's save something. So we don't do it again. Mark.
Underscore.
As I was noting right now, you can,
Yes, right.
if you do that Mach number, it's because you didn't change the air to ideal gas. And if you don't change the air to ideal gas, basically Fluent is not considering, is not calculating even the sound of speed of the air. So you will not be able to calculate the Mach number.
Okay.
Okay, so then let's continue here. Y0 is
Compute.
-0.005. Also Y1 is the same value. And then Z goes from 0 to, we can set this to 0.1. If you are unsure about dimensions, you can go either in general scale or on the top here, domain scale, where you have the domain extent. So you can check what are the dimension, let's say, of of the geometry. So for example, the Z max is 0.09. So if I set Z 0.1, it means I'm covering the whole domain. And create. So on this line, in my results, I can plot. I can create an XY plot. For example, for the Mach number, if you want to get the exact value of the Mach number there, so we select the y-axis function velocity, and then we select Mach number. And here we select in surfaces our line, so x equal minus 4h. So we can plot the no, before that we need to change the plot direction. So this is in the z direction, the line, so we set plot direction x equal to 0 and z equal to 1, and we can save plot. So you'll see that this is the Mach number. It's if you approach the line from the bottom, you get 127. If you approach it from the top, 1.29. So don't trust those values. I mean, your solution will be somewhere there. If you want the exact value, you should write to file so that you get the point by point value, and then you can check the solution. However, this is almost exact, so it's 0.228. So let's take it for good. And so your domain here goes from 0.01 meters to 0.09. So that means that the center of the channel will be at 0.045. So that's the value you need to consider, the value at this point. So then, this is for the Mach number that we use to check that the solution is correct. But then we need also to calculate the infinite values. So pressure, density, and velocity at infinite, and infinite stands for the reference point, which is that exact same point that where we are checking the Mach number. So for the same XY plot, we can double click in here, and we can even plot the velocity magnitude. And then we can extract the value of the velocity. You can do that again by writing to file. And then we can do the same for pressure. Here you can see the pressure distribution. You can get the value at the middle, and also for the density, which is basically constant to 1.16. See, this is an incompressible case. So let me write the results I got for this infinite. So I got U infinite equal to 44.2 meters per second. P infinite equal to 99,846 pascals, and rho infinite equal to 1.16 kilograms